Welcome. This is Exponential Functions 5.4. We're just going to talk about dilations. Right now, dilations, if I have a point, let's say it's 2, 2, and I want to dilate it, a dilation means that it's going to enlarge in all directions. So let's say I dilate it by a factor of 8. I would move out on this x-axis 8 times this distance. So the distance there is 2. So I would go 4, 6, 8, 10, 12, 14, 16. But then I also need to go from the y up a multiple of 8. So I would be out at 16. So that is to show you that a dilation increases in both directions, whatever your factor is. Okay, so if it's a dilation of 8, it would be 8 times 2 would be 16. And a dilation also on the y, which is 16, because I had 2, 2. Okay, now on a vertical stretch, vertical is up and down. Horizontal is right to left. Sorry, I left out an L there on my horizontal. Okay, so these are a little bit different from dilation. On the vertical stretch, what happens is this point just simply stretches vertically. So it becomes, if it's a stretch of 8 vertically, then it goes from 2, 2 up to 16, I'm sorry. To 8 would only be a stretch of 4. To 16 is you're taking this and multiplying it by 8. So your x doesn't change, but your y does. Okay? Now, in a horizontal stretch, I'm hoping that you'll all guess, it would be stretching it this way, so it would be the x that's changing. If it's a factor of 8, you'd take the x, multiply it by 8, and that would be 16 on the x-axis. But the y doesn't increase because it's not being stretched, so it would be 16 too. Next, we want to look at exponential functions. Just adjust my camera slightly. Okay. On exponential functions, I hope that you're thinking, okay, I know that these are related to the geometric sequences. So if we think Fn equals F1 r to the n minus 1, we can kind of relate. F1 was the number right here. However, this was raised to n minus 1. This no longer has n minus 1. So instead of this being a first term, that's where we're going to subtract 1. This is at your 0. So let's just choose a sample amount for b, because we're going to change the a, we'll keep the b constant. Let's say b is 2 to the x. That's an easy one. Okay? Here are our x values. If it was a sequence, we would start at 1. So 2 to the first would be 2. Now if a is 1, then 1 times 2 would be 2. If a is 1 and 2 is raised to the second, that would be 4. 4 times 1 would be 4. If a is 1 and x becomes 3, that would be 2 to the third would be 8. And I hope you see we're growing just like your sequence did. Now, because we're graphing exponential functions, unlike the geometric sequence, we actually go into the 0th term and we go into the negatives. So that's something new. We're going to have the 0th term, -1, and -2, because on the graph we would graph those. Now, because anything to the 0th power is 1, your 0 value is always equal to your A value. Okay? Since we see our A value here, 1/2, 2 to the 0th. Anything to the 0th power is equal to 1, so 1/2 times 1 is 1/2. 1/2 times 2, oh, I'm sorry, that's 2. My A value is 2. 2 times 2 to the 0th would be 2. 3 times 2 to the 0th would be 3. Because anything to the 0th power equals 1. Now let's go ahead and come back and fill these in. I hope that you notice A is your starting point. Okay? So on the y-axis, it's crossing at 1/2 here. It's crossing at 1 here. It's crossing at 2 here and at 3 there. I kind of look at the y-axis as the starting point for the graph. Now, hopefully you're saying, yeah, this is your growth factor, so we're just multiplying by 2 as we go down. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. We can plug it back into our formula and figure out that way too. 2 to the first is 2. Half of 2 is 1. 2 to the second is 4. Half of 4 is 2. So do you see here how you're still multiplying by 2? Your 2 is your growth factor. So this will be 4. This one, 2 times 2 to the first. 2 times 2 is 4. 2 times 2 to the second. 2 to the second is 4 times 2 is 8. 2 times 2 to the third, that's 16. So I hope as you look at these final values here, you can see that as A increases in size, our answer increases by that same factor because we are taking that A value to multiply whatever the answer is. So when A was at 1, we just have the growth factor. When we take A up to 2, then we take the growth factor and we're multiplying it by 2. Or we take A down to 1/2, we're taking the growth factor here and taking half of it. Now going up into the negatives, we would have 1 times 2 to the negative 1. Now 2 to the negative 1, remember, is equal to 1/2. Because we put it on the bottom, so it's 1 times 1 over 2 to the first, which is 1/2. So it'd be 1/2. You can look at the pattern here. What times 2 equals 1? It would be 1/2. So going even smaller, that would be 1/4. Smaller, 1/4. Smaller, an 1/8. You can follow your sequence here in numbers if you'd like to. 1/2 of 2 would be 1, or you can go 2 times 2 to the negative 1. 1/2 to the negative 1 is 1/2. So we can get it either way. These are what you would graph, and these. So looking at that, this first one with 1/2, if we bring back out our graph here, A being 1/2 and 2 to the x times 2 to the x, what was happening is that it was starting at the y-axis at 1/2 and then it was increasing by 2, like that. You could connect the line. That's not a discrete when it's a function rule. Now, when we had A at the value of 1, remember at our 0, it was 1. Now it's doubling as it goes to the left. Oops. So now that is 1 times 2 to the x. Let's go over to the 3. What we can see is going to happen there is that y equals 3 to the 2 to the x. We're going to start at 3 on our y-axis, so we go up to 1, 2, 3. But it still doubles, so when we go to our first one, 2 to the first is 2, 2 times 3 is 6, so we go up to 6. Okay, that should give you an idea. Now, if we go into the negatives, the curve just continues off this way. Remember, going half the height of the one before it as you go to the left. Okay, so that's what happens when your A changes to your graph and to your equation. We're going to play with some of that in class. Now, these are exponential functions with the b value changing. What was that b value that raised to an exponent? When you were in your geometric sequence, it was an r. I hope you're saying that's the growth factor. That's how much you're multiplying it by as you go to the right. So this time, let's put the 2 in for a. Let's say that it's f of x equals 2 times, and then we'll have the b to the x. Okay? So anything to the 0th power equals 1. So 2 times 1 is 2. So the whole way across here, it is 2. Now, I hope you realize what that means. That means as we graph the b values changing, that they're all going to cross right there at 2. Because that is our x equals 0, that's your y-axis. So they'll all cross at 2. Now let's see what happens here. We have 2 times a fourth to the first power. That would be 2 fourths, or equal to 1/2. 2 times a fourth to the second power. That will end up being 4 squared is 16, so 2 over 16, which is 1/8. Let's go up into the negatives now. 1/4 to the -1 would actually flip over, and it would become 2 times 4. So that is 8. And -2 would be 2. 1/4. Raise the -2nd, flip it, would be 2 times 4 squared. 16 times 2, 32. I hope you noticed, being your growth factor, that you were going to divide by 4 the whole way down. On this one, maybe you're already saying, oh, you're just going to take this and you're going to cut it in half. You're correct. 1, 1/2, 1/4. Going up, going backwards into your negatives, you would be multiplying because you're going backwards, so it would be 4 and 8. Because as you go down that list, you should be cutting them in half. Now what happens if we have b to the first? Remember, that's your growth factor. That means you're not changing. Because 1 raised to any power is 1. So I hope that makes sense. That is not exponential. If we have 2, growth factor of 2, then we would go 2 times 2 to the first would be 4. 2 times 2 to the second, that would be 4 times 2 is 8. So as we go down, we're multiplying by 2. As we go up, we could go backwards. What times 2 is 2? 1. What times 2 is 1/2. Okay? Start getting really comfortable with these exponents. So let's graph this with the change in b value. We know at 0 everything's going to cross at 2. Let's go for the b to the 1/4. On the b to the 1/4, we know that each value is cut or divided by 4. 2 divided by 4 is a half. Going back here at -1, it was up at 8. So that's a pretty steep curve. Doesn't touch 0, but it comes down there pretty fast. Okay, let's go up to the b to the second, or not b to the second, b equaling 2, a growth factor of 2. Now when it crosses at 2, it's growing. So 2, next one would be 4, next one would be 8, one before it would be 1.5. So this is 2 times 2 to the x. This one is 2 times 1/4 to the x. That's what a growth rate does. This isn't a growth rate, is it? I hope you're saying that's a decay rate. Come to class ready to play with these.